Hi, my name is Rafisa binti Zaiful Azmi and I will start today's presentation with introduction. In radiography, X-rays first create an image that cannot be seen, which is called as latent image. Then after processing, it becomes visible and can be used for diagnosis. This formation of the latent image is explained by the Gurney-Mott theory and Mitchell theory. These theories describe how X-rays interact with the image receptor through processes that will be explained further by my fellow friends. Understanding this basic concept helps radiography students know how X-ray images are formed and why a proper exposure and processing are important. What is latent image? By the definition, it means an invisible image on an exposed film that has not yet been made visible by developing latent. It contains all the information about patient anatomy that has been examined. This latent image only becomes visible after a development process. The production of latent image is the first step of the photochemical process. What about a visible image? By the definition, it means an image that can be seen by human eye after processing, formed from the latent image. When a photographic film is developed, the area that was exposed darkened and formed a visible image.
Assalamualaikum and good morning everyone. My name is Nur Ilian Anissa binti Zakaria and today I will talk about Gurney-Mott theory. So, Gurney-Mott theory explains how an X-ray film forms an image when used with an intensifying screen. It focuses on the role of light and electrons in forming the latent image. So, when an X-ray examination is performed, the X-ray beam first strike the intensifying screen, not the film directly. The intensifying screen contains special phosphon crystal that are very efficient at absorbing X-ray photons. So once the X-ray are observed, the screen convert the X-ray energy into visible light. The step is important because light is much more effective than X-ray in exposing the film. The light produced by the screen then travel to the film emulsion, which contains silver halide crystal. According to the Gurney-Mott theory, when this light reach the silver halide crystal, it provide enough energy to release electron from them. So this release electron move within the crystal become trapped and specific site called sensitivity spec. The electron attracts silver ion and reduce them to metallic silver. As more metallic silver atom collect at this sensitivity spec, a latent image is formed. This image is invisible at first, but during film processing, the areas containing metallic silver are developed and become black, creating the final radiographic image. So why this Gurney-Mott theory important? It is because it explains why intensifying screen are used in radiography, and then it shows the field exposure mainly comes from light, not directly X-ray, and then it helps reduce spatial radiation dose because less X-ray exposure is needed. So in summary, Gurney-Mott theory explained that light from the intensifying screen release electron in the film, which form a latent image that become visible after processing. So that's it. So I will continue with the Mitchell theory. So Mitchell theory explains how X-ray film is exposed directly by X-ray without using an intensifying screen. So it's kind of different from the Gurney-Mott theory. So in Mitchell theory, the X-ray photon directly interact with the photographic film. When X-ray strike the silver halide helix crystal in the Philip emulsion, they have enough energy to release electron from this crystal. The released electron then move within the silver helix crystal and become trapped at sensitivity spec. This electron attracts silver ion and reduce them to metallic silver. So same goes with the Gurney-Mott theory. As more metallic silver atoms at this site, a lattice image is formed. This image is invisible at first but become visible after film processing, where the exposed area turn black. So the things that we need to remember is Mitchell theory. Exposure is caused by direct X-ray, not light. No intensifying screen is involved. More X-ray exposure is needed compared to screen filament system. Image detail is high, but patient dose is higher. So, in conclusion, Mitchell theory states that X-ray photon directly release electron in the field emulsion, forming a latent image. So that's it. Thank you.
Assalamualaikum and hi, my name is Nur Amira Alfa bint Hashim. So today I will be presented about the process of growth in Bode theory. So growth of the latent image refers to the enlargement of a small sub-image center into a stable latent image center, which require at least 10 silver atoms. So this process begins at deep electron traps, which have stronger electrical attraction. Electron and silver ions are drawn to this site, where the silver ions are reduced to metallic silver. As more metallic silver accumulates at the trap, the cluster of growth forming the latent image center. Next is developer reduction reaction. In the developer reduction reaction, the developer acts by supplying electrons. These electrons are taken up by silver ion, which are then reduced to metallic silver. The metallic silver atoms accumulate at the latent image, hence causing the image to grow and become visible. This growth process is identical in both theories, as it simply involves the accumulation of metallic silver atoms. In the end, both pathways result in the formation of a stable development center. Lastly is electron traps, which is called sensitivity spikes. It is a low energy sites inside the silver halide crystal. They are essential because they capture free electron after photon exposure. Once trapped, this electron attracts silver ion, forming a silver atom. More atoms gather, they create clusters known as a latent image centers, which remain invisible until chemical development. The crystal lattice provides the pathway for electron to move toward this trap. Finally, the sensitivity of the film depends on how many traps are present, as well as the size and distribution of the crystal in the emulsion. That's all from me, thank you.